This section involves e to the x, both derivatives and integrals. I'm going to do two separate videos of those. This video is just for the derivatives. The next video will be just for the integrals. That way, if you want to review one or the other, you can just go watch that one video. But we need both videos put together to do this assignment here for this particular section. Here's a really neat thing. This is super easy. The derivative of e to the x is simply e to the x. You get the same exact thing right there. Now you got to be careful if the powers are different, but the derivative of e to the x is e to the x. At the end of this video, I'll show you a mini proof for why that's true. But that guy, he could dress up, the e to the x guy could dress up for Halloween as e to the x. And you want to know, be like, man, dude, are you yourself? Are you the derivative of yourself? Like, you can't even tell, you know, unless you like color code them or something like that. But hey, the derivative of e to the x is e to the x. So like, here's your property that you're going to add to your property list from this chapter. If you have e to a power, the derivative of that is going to be e to that power times it by the derivative of that power. So here's how it works. If I have y equals e to the 2x, when I do the derivative of e to the 2x, I'm going to get e to the 2x. I just rewrite it down, and I times it by the derivative of that power. So the derivative of 2x is just 2, so we get 2e to the 2x as our derivative. All right, so right here, you still got to ask yourself, anytime you're doing derivatives, you got to ask yourself, what is that? Is that a power? Is that a product, quotient, trig problem, logarithm? This right here, you're multiplying the two things together. This is a product, which means we must start off with our product rule. So when we do our derivative, we're going to go first function, just write it down. And then we're going to times by the derivative of the second. And here's our new property right here. So if I have e to a power, when I do the derivative of that, I get e to that power, just write it down. And then you times it by the derivative of that power. So the derivative of negative x is just a -1. So I did first times the derivative of the second, and then we're going to go plus the second function, just write it down, times it by the derivative of the first, the derivative of that x squared is just going to be a 2x. Still do your normal habits that you've been doing ever since we learned derivatives. If you do a GCF with the variables, go ahead and do a GCF. If you need to get one single fraction, get your one single fraction there. So right here, I have an x and an e to the negative x I can pull out as a GCF. And that's going to leave us with a negative x plus 2 on the inside. And then if you have an easy negative exponent that you need to get rid of, go ahead and do that like we always do there. So I'm going to have just a negative x plus 2 on the inside. I can drop that e to the x down to the bottom. And there's our first derivative right there. Remember, everything you know about first derivative is still true. If they say find the slope of the curve, the slope of the tangent line, that's what you do right there. If I'm doing a max or min problem, or if I'm doing, you know, increasing, decreasing stuff, and I need to set the tops and the bottoms equal to 0, that's why we do the GCF. That's why we get the one single fraction. I can set these equal to 0 for the horizontal tangent line, vertical tangent lines, do your normal stuff there, but just practice doing derivatives of different things in this exercise. So it's just review what you already know how to do, but then now we're just going to add in that e to the x right there. So final problem. When you remember from the first section of this chapter, if you have the ln of something, I stress you do your pre-calc properties first, right? So we got our pre-calc properties. If you have the log of a product or a log of a quotient, break that stuff up, expand that stuff out, and get rid of that. So I'm going to rewrite this original function. I'm going to do the log of the top minus the log of the bottom. Do not make those too complicated for yourself there. And now I'm going to do the derivative of each one separately. So it's just like the first section of this chapter, when we do the derivative, have the ln of something. Remember, we do the derivative of ln of something, you go 1 over that something, and then you times it by the derivative of that something. So the derivative of e to the x is just e to the x. And then the same thing here. We have the log of something, so I'm going to go 1 over that something, and I'm going to times it by the derivative of that something. So the derivative of e to the x is e to the x, but then the negative's out there. So it's going to be a negative e to the x. And then here's the thing, like separate it before you take the derivative, because that makes your derivative easier. So you have the calculus is done. And now what we got to always do, anytime you have a derivative and you have a couple fractions like that, you got to get yourself one single fraction. So what I'm going to do is multiply those two denominators together. That's going to be my common denominator. And then it's like I'm squeezing in a 1 minus e to the x on the top and the bottom here. So we'll just have this. And then when I do minus and negative, that's going to become plus a positive. And I'm squeezing in a 1 plus e to the x on the top and the bottom here. And then that top part looks pretty simple there. You got two options there. You can either factor out an e to the x because you got an e to the x for both of those terms. Or I think on this one, it's just pretty easy to just go ahead and just like distribute that real quick. So I'm going to just distribute that. Now, when you go e to the x times e to the x, remember, like if you have x squared times x to the 5th, you're adding those exponents. So x plus x will give you a 2x right there. And then distribute this guy. And then these e to the 2x's cancel out. So you got 1 e to the x plus another 1 e to the x. That's going to be 2e to the x. Now on the bottom part there, if you want to leave that just like this, you can do that. If you want to just multiply that all out, you could also do that there and have that as your final answer like that. But like I said, you could just kind of leave that multiplied all out. We are skipping over that one section. This is not really, it's just the pre-cal stuff we already reviewed there. But the one section just talked about how the ln of x and the e to the x graph are inverses of each other. You know, they're symmetrical over that y equals x line right there. But we should know the ln of x graph. We should know the e to the x graph. We also reviewed this already before, your main definition of a log, where if you have log base b of a equals c, you can make that b to the c equals a. That works for the ln's as well. That's just automatically base e, so you can go e to the y is equal to x. And we got to know these without the calculator. If you're interested in the mini proof for why the derivative of e to the x equals e to the x, that's what I'm attempting to show you right here. So if you don't care about that, then you just end this video. But if you cared about it, there's two different ways you could prove this one. This is just a little mini proof right there, but I'm attempting to prove that the derivative of e to the x equals e to the x. That's what that notation means there, is this derivative of this equals that. So what I do, when you want to prove something, let's start with something that's true, right? We should know that the ln of e to a power is just that power. That's what we reviewed in our summer packet right there, because this ln, this is like a base e down here. So those bases just cancel out, and that's equal to x. So this first step, this is something we're starting with that's true. And what I'm going to do is take that step and I'm going to do the derivative of both sides. That's what that notation means. So I just carry down the green and I'm going to do the derivative of both sides. Now the derivative of that x, that's 1, right? When I do the derivative ln of something, if we use the ln property that we used before, right, the very first section of this chapter, when you have the ln of something, remember what we do. We do 1 over that thing. So I drop that down to the bottom. And on the top, I do the derivative of that thing. But right now, it's like I'm proving this, so I don't know what the derivative of that e to the x is. But so then I have this equation. Now, if I'm trying to solve for this guy right here. So if I just multiply both sides by the e to the x, you get the derivative of e to the x equals e to the x. Please remember to watch the next video over the integrals, and then we'll have everything together there.